Hello and welcome to a series of videos I want to make about the OWASP Top 10. The OWASP Top 10 are the list of the 10 most serious web application vulnerabilities, and the OWASP organization themselves describe what they are, how you would notice them, how you would recognize them, how you might take advantage of them, and more importantly for us as developers, how to fix them and stop them from being vulnerabilities in our web applications. Sadly, in 2015, we're still seeing thousands and thousands of sites hacked on a daily basis, purely because developers are not following any kind of best practice with their development processes. And many developers are almost completely unaware of how to code securely, and it's not helped by the fact that a lot of people have books, textbooks, tutorial books, information they've taken from the web, which is actually written in a very insecure way and which has just been copied and pasted as is. So I want to spend one video looking at each of the top 10. Some of the videos are going to be longer than others because they have specific code that we can demo and I can explain what the vulnerability means. Others are more conceptual and or otherwise very short topics that can be described very quickly, but I'm going to do them in severity order. And A1, which is their designation, is injection attacks, and it is considered the most serious of all of the OWASP top 10. So SQL injection is what happens when we take data that is untrusted. By definition, any data that we take from the browser is untrusted, even though we expect that it's come from user input and we assume that we know what the data will look like. But the reality is somebody types in data that we don't expect, either by accident or more often on purpose, and our query or interpreter that we're using ends up doing something that we don't expect as a result of that. So usually an attacker enters data that does not fit the expected input and malforms it in some way to have either unintended consequences or, in their case, something perhaps that they're trying to do, such as error leakage so they can get more information about the system, perhaps damage to data, or just simply to be able to read data from the system that they shouldn't be able to read. One of the things that a lot of people don't seem to realize, which again is very worrying, is that an attacker can bypass any client-side controls that might be intended to stop this. So any validation that you have that exists only in the browser, only in JavaScript, is not enough protection by itself, because an attacker can simply modify that code and can call your page without calling any of the validation routines. Now, usually an injection attack is related to SQL, but it can also apply to LDAP if you're querying Active Directory, operating system calls. In fact, anything where you're taking data from the user input and applying it to some sort of query. Now, although it's not the most common vulnerability in web applications, cross-site scripting, which is the next video covers that, it's considered the most serious vulnerability, and that is for two reasons. If the site is susceptible to injection attacks, it's usually very easy to take advantage of that, and I'm going to demonstrate that in a second on one of my example applications. But not just that, it's also usually very easy to find out if a site is susceptible to SQL injection attacks just by putting various test data into input fields on forms and seeing what happens. Another problem is that many frameworks are either vulnerable by default, so a lot of them don't necessarily have any kind of protection built in, or maybe the database patterns that they describe by default are not very strong. But also, most frameworks easily allow the vulnerability to take place. So it's quite difficult for a framework to stop people doing something wrong. But unless the defaults are strong, then it just makes it even more easy for developers to misunderstand what they're doing and to create injection vulnerabilities as well as other sorts of vulnerabilities as well. As I mentioned before, there are many examples in textbooks, many examples of code used online that is vulnerable to injection. So it's not good enough for a developer just to say, I got this from a book, or I copied this from a Stack Overflow question or something like that. You know, as developers, we need to start taking our trade more seriously. We need to learn what these things mean, and we need to find out, firstly, whether our applications are vulnerable to injection, and if they are, we need to work out how we can stop them being susceptible. So let's pop over to my demo bank account application. So what this kind of looks like, I mean, we got kind of different pages and none of them are particularly interesting, but here I've created a page called bank accounts, and the basic idea is if you want to create a new bank account, you type in the name of the person, like Luke Briner, and you hit create account, and it says account created, and we can verify that. We can go back to, this is the database table. I've just got this stored in local DB, which is a nice convenient way of developing things locally. And if I refresh that data, it shows me I now have an account, name Luke Briner, balance of 0. And just in case you don't believe me, I'll add a second one called, let's say, Mark Briner, and we'll go back here and we'll refresh the table again, and you see I've now got 2 accounts. So that's basically what the application is intended to do. Now, the problem with a lot of developers, we think very much in terms of functionality. What we don't think about is what happens when people don't do what we expect them to do. So, okay, somebody could mistype something and they could kind of accidentally type something like that, and that might be fine. If we go back here, I don't know what's happened to that, but there you go. So it's kind of added all that as a name, which is great. Even though that might not be quite what we wanted to do, it doesn't seem to be a problem. It's not broken. It just looks a bit strange, and probably we would need to correct that at some point. But the problem with SQL injection is SQL injection says, right, let's assume that under the covers, the SQL that's going to put this data into the database has not been written in a very secure way. So one of the first things I might do is I might assume that probably this is going to be put into some text. The value will be closed by a single quote. Probably it's being inserted using values, you know, blah in brackets. So I'll close the bracket. I'll then put a semicolon in. So that's going to terminate the statement. The other thing is right at the very end, I'm also going to put a comment character, so anything else in the code that's going to be stuck on the end is going to be ignored. And now I can kind of put whatever I want in here. And I'm going to assume that this is going to be some kind of SQL statement. But let's say, for instance, I just do something silly like that, and I hit create account. Now, there's 2 things that are a problem. The first thing is that this site is susceptible to SQL injection, because that shouldn't have caused an error. But it did cause an error. The second problem is that I have custom errors switched off, which means that this error is going to fall over, and in this case it's going to show me some code. Now this is a big no-no. This is one of the other top 10 issues, which is about error exposure, data exposure. But just very quickly, what we can see here is the exact SQL that is being created by that page that I've just been on. So it's inserting into a table called bank account. Now I didn't know what that was called before. I could have guessed, but in this case it showed me exactly what the table's called. It showed me that there's a column called name amongst other columns, and it's just chucked my stuff straight in. So straight away I could potentially do different things. So I now know it's called bank account. So if I was being very bad, I could do something like delete from bank account. So guess what's going to happen here? It's going to insert the new account like normal, and it's going to delete everything from it's going to delete everything from the bank account, and it's going to ignore everything else that's added after the code. I hit create account. Now this is going to run okay, and it's not going to error because this is valid. Nothing like illegal has happened as far as the system's concerned. However, what has happened is not what I expected as a developer. So I've not thought about what happens if somebody's going to start typing in stuff like this. And the reason is quite simple. If we look at the line of code at fault, the problem is effectively I'm entering data as text, and at this point there's no meaning to it. It's just text. The system can't tell whether this is correct. It can't tell whether it's being used in a correct way. At the end of the day, I'm just creating a string, and it's only when I execute it that it's going to be interpreted as a SQL statement. So the compiler itself is going to have no way to tell whether that's formed correctly, and no way to tell whether I've typed in the right thing. There's no validation, there's no nothing. So hopefully you can see there quite clearly where the problem is. If you want it to be a bit more explicit, if I copy that, and let's put that in Notepad for a second, just so we can see it. So that's the statement I'm trying to build up, and what I expect to happen is something like that. That's valid SQL and it runs okay. But what we're saying is, what happens if, instead of just typing in a name, I type, let's copy that and paste that in. Now notice here that because I've been a bit bad, I've still created a valid statement, still going to insert into a bank account, because I don't actually have control over this part of the SQL statement. That's already in code, so I can't change that. But what I can do is just do something random, insert an account, doesn't really matter. And then by using this, I can create a second statement doing whatever I want to do. And then I'm going to comment out this, which is the last bit that the code here has added on the end. So it's commenting out those last bit characters there. So that's what's happened. What's happened is my application's designed around what I thought was going to happen, and because somebody's done something different, they've caused an error. Now, depending on the system, depending on how the errors are echoed back, I mean, maybe, I don't know what happens if I do select star. I mean, this will probably run, but it won't do anything, because I've actually called execute non-query, so it's not going to return any information. But if I was calling, you know, execute data reader or something like that instead, then I could very much end up writing out a list of bank account names down here, passwords, you know, could have kind of be anything. I can also find out whether tables exist. So if I try to find out if that table exists, I'm going to get an error, because it's going to say I don't know what user blah, 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 blah is. But what happens if I try user? Is that a table? Nope. What about if I try users? Is that a table? Yes. So I now know that's a table. Even though I haven't got anything back, because it did an error, I know that that is a valid table name. So straight away, this one tiny little vulnerability has given me access to lots and lots of potential information. So even if I can't select star from users, I could delete from users. Now, I'm not going to run that, but if I run that, clearly something bad is going to happen. So that's what SQL injection is. In terms of fixing it, the good news is it's very easy to fix it, and we need to fix it in two places, really. When you're building a new site, basically do it properly. If you build your sites properly, if you have a process, either any process at all for security, you'll probably do it properly. And we're talking about validation, and we're talking about the database layer. So the database layer of code that goes between your application business logic and the database, if that's written properly, then all of that benefit is applied to your entire application, as long as you obviously use it properly. Whereas if you just try and fix it in one place, then you could easily make the same mistake in a different place and still have the problem. So if you level your functionality properly, and if you have a shared database layer, so everything goes through the database layer, it's much easier to protect against it. Updating an existing site is potentially going to be much more difficult. Obviously, you might not have access to the code. It might be complicated code. It might be a very large code base. There could be a whole load of reasons why it might be harder. But really, I don't think it's an option to not do anything. You're going to have to do something at some point in time, the sooner the better, to stop people attacking your sites. This is such a common vulnerability. So there's two ways we can fix the database, or fix access to the database. And I've got the other examples here. So instead of doing that, one of the easiest ways to do it is to use parameters and placeholders. So I don't really change very much. Rather than building up a string, I still create a string, but in this case, by using this @ syntax, I can put in named parameters. So in this case, a parameter called name, and then I can add into name the parameter that I want to add in. So I haven't really done a lot more than I did before, but just by doing that, it means that the system will automatically quote everything within that value, but also it will escape any characters that appear in this text box that are not expected, like single quotes and stuff like that. So let's prove that that still works. So if I go back to here and we run this, and I call create account again, That's now succeeded, but this time what's happened is, well, hopefully what's happened, if I rebuilt it. No, because I didn't rebuild it. Let's go again. It's just going to reload a second. So if I do that and I run it again, and I refresh this, what's actually happened is because it's quoted and escaped everything that's in that text, it hasn't interpreted this as additional SQL. It's basically interpreted it as a single string and it's inserted it. Now again, this is wrong and this is not as expected, but it hasn't done anything seriously. It hasn't fallen over and it hasn't had unintended consequences as far as we can tell. Clearly in a real bank system it would be very complicated and possibly would have knock-on dangers with funny characters in names. So that's the first way we can do it. The second way we can do it, although I haven't actually wired this up, but I'll show you what it looks like, is instead of using text, we can change that to be a stored procedure. So we set the type to be stored procedure. We have something like called proc create account, maybe, and then we pass in the name. And again, we attach the parameter in this way, just like normal. And the beauty of this is we get to lock down the permissions on the database much more tightly, because what we can say is the connection from this web application is not allowed to delete, select, update, drop, or anything like that. The only thing that the connection is allowed to do is execute stored procedures. And by doing that, we can restrict the application so that even if it was hacked, even if somebody found out the code, even if somebody found out your connection string, login and password, they wouldn't be able to do things like select star from user, because you're just not allowed to do that with stored procedures. It takes a bit more work and you can't always do that because things like active record and stuff, entity framework, they need direct table access to do what they do. But if you can do stored procedures, that's kind of the best idea. So we can fix the database in one of those two ways, but let's just go back to one that works. Another really important thing that always works hand in hand with SQL injection protection is input validation. And I can't overstate this. Every single user input should be validated on the server side in as restrictive a way as possible. So it's no good just saying, oh yeah, it should be okay. You know, we can very easily, I've got one in here ready to go. I can go in here, I can add in this case a regular expression. And what I've said in my regular expression is I will let you use A to Z lowercase, A to Z uppercase, a dash, because you might have a double-barreled name. You can have up to one space, and then you can have the same thing, but you could also have an apostrophe in the second name, so like O'Reilly or something like that. Now, that's not going to be perfect, and we'd have to test, you know, to make sure that that all works. The other thing that's really important is in our code that we call this. And again, really easy, put it on your code review checklist. Every single event handler should call page.validate, and if not page is valid, return. That bit I've added just as a sanity check, but you wouldn't necessarily have that in there. But those two bits, page.validate, if not valid, return, put it in every single event handler. Even if you don't have validators on the page, put them in anyway, because then if you do add a validator, you're not going to forget to add that bit in. Now what happens, which is, you know, kind of makes sense. Oh, let's go back to here. So if I reload this page again and I bring up, hang on a second, bring up one of these weirdo ones like this, and I hit create account. This name contains invalid characters, only allowed A to Z apostrophe and a dash. And I go, oh, so I could have, you know, Luke O'Brien, that would be allowed. Bang, so that works. Now notice that this is a very simple regular expression, so it doesn't look for, you know, things that are clearly wrong. It's only really saying kind of letters and dashes in the first name. You're only allowed two names because you have to have one space in the middle, and then, you know, letters, dashes, and apostrophe in the second name. So this would also be valid because it still matches the regular expression. Clearly it's wrong, but it doesn't actually matter too much. You know, we've got to be a bit careful, because if we're allowed dashes, again, we've got, that could still do something dodgy with the SQL. So regular expressions are not usually perfect, If we refresh that, we'll see all those that have been added. They're not usually perfect, but with a combination of a validator of some sort, maybe more than one validator, depending on what the data is, and then also using either parameterized queries or stored procedures, then you can pretty much nail SQL injection on the head really, really easy. Don't rely on input validation alone, and the reason I've said that is, like I say, the regular expressions for validation are unlikely to be perfect. There are likely to be edge cases. There are times when the characters that they have to type in will actually could potentially cause a problem, so you should also have those database controls. But basically that's all there is to SQL injection. It's fairly easy to understand, but like I say, also very easy to abuse and attack, but also very easy to fix. So any questions or comments about this, please let me know. Otherwise, as you can see, the next video is going to be about authentication and session management.